Okay, new spreadsheet. Is the data really linear? So you want to get this. Again, you want to make a copy, put it in your Google so you can edit it and follow along. We're going to look at the is it linear tab, and we're going to figure out how we can determine whether data is linear or whether it's maybe just a little random noise in there. You then have 3 practice tabs there that you can work on using this spreadsheet and doing some calculations and some graphing. It'll kind of just build your skills if you're just new to this. So let's go to the is it linear. Okay, so what this spreadsheet does, it's got one new feature that you have not seen, and I'm not going to explain how this works because that's going to be the next one when we build an actual simulation. But I've thrown 2 variables in here that will alter the data. I can change a curvature factor, and really what I'm going to do is on the red equation, I'm going to mess with the exponent, which if I keep it 1 is linear. If I drop it below 1 but still keep it above 0, it'll do one thing. If I take it slightly above 1, it'll do another thing. Okay? That curvature factor will only influence y2. The other error that we're going to look at is random error. Okay? And the random error is initially 0, and then I can take it as high as 5. And the random error will influence y1. Okay, so what we will do is we'll mess with one factor at a time so that you can see curvature in y2 and compare y1 with no curvature, no random error, and then we will set this back to 1 and mess with random error, and we'll have y2 as a comparison. Okay, so what we're going to do is and also again, beware, that little black mark in the cell means there's a note. And here we want to set something great, keep it greater than 0 and as high as 2. We'll put in a 1.3, excuse me. Put the 1.3 in and Google finally catches up. Okay, now we have altered the linear equation. Okay, we've increased its slope. We now have a size, or we don't have a 0 intercept. And notice we have still a very good r squared. But is this data linear? If you look at the red curve, down the bottom here at low x values, you're above the curve, on the curve, below the curve, below the curve, below the curve, maybe on, and then you're back above. Okay, you've got a pattern, and if we calculate something called the residuals, okay, where we take the data point, the y2 values here, and subtract the regression equation values. Okay, notice we have no residuals. They're all perfect at 0, but our y2 where we added curvature, notice that the residuals are smiling at you. And if you go back here, the data is actually smiling with the over, under, over. Okay, and anytime you get a distinct pattern in the residuals, it's a really good sign that you don't have a actual linear data, okay? That there is curvature, okay? And the residuals show you they're above, below, above, okay? And it's a good way to point it out, even though that y2 linear regression has a good r squared. R squared can't tell you if it's curved unless it is really blatantly obvious, okay? If you had a good bit, I'm pretty sure if you put a 2 in here, you'll get a distinctive sign. Now you can really see the curvature, and the residuals just to get to be really sizable numbers now and show it to you. Okay, so that's how we detect curvature. Okay, we use residuals. A little bit can tell you lots of things. This is one basic thing to spot a linear system. I'm going to take my curvature out now. And I'm going to add some random noise. Again, I'm going to check what it says. 0 is no random error, random noise. I can go from 0 to 5. I'll just nicely take, we'll take 3. Okay. So what happens if I add random noise? Random noise is going into the blue data. There it is. Notice my slope actually stayed the same, but now I have a slight intercept, and excuse me, I've dropped the r squared a little bit. If we go down and look at the residuals, what you'd like with random error, the hope is the residuals show a random pattern. Okay. It may not be perfect here. Again, here, you know, negative, positive, negative, positive. You get some negative. You get some positives, a string of positives in there. Here's the neat thing: random error changes the slope, the intercept, and the r squared in a random fashion. Okay, so to kind of demonstrate that, if you do Control R, the spreadsheet will recalculate, okay? And notice when it does, your slope can be lower. You get a different intercept, okay? Again, yeah, you kind of have it surely is not a distinct pattern in the residuals, okay? But one thing about random error is you don't get the same, you may not get the same exact thing every time. So it's worth kind of playing with. Okay, now you have a slightly higher slope. Okay, and again, definitely not a pattern. Now, if all were great, the positive residuals added to the negative residuals should be 0, but all is usually not that perfect. Okay, so what you've got in the rest of this spreadsheet is checking two different sets of data by calculating the residuals to see if you have curvature or it's just random noise. And then you have a case where, if this thing will flip, we've got a set of data. Is this data got some curvature? Wow, that's a really good r squared. Can't really see much there, but if you look at the residuals, better yet, if you go look at the plot is smiling at you, so yes, it is curved. Can you hide that curvature by adding random error, or what sometimes is called random noise? And I'll let you play with that to see if it does it. Okay, well, that's, you know how to compute, you know how to graph and put a model on. You've now seen how when life throws you a curve, how you can detect it if there's curvature in data. And there are many cases where that happens. Okay, you learned the new way. The new way is to use the residuals. Now, what you might be interested in, how do I do this to get the interactive nature where I throw noise or I can change a variable? And that's building essentially a simulation, and that's going to be our next video. So if you'd like to see how to build a fancy simulation, stick around and check out the next video.